UFO?
UFO.
Do you mean IFO?
I mean UAP.
Aha, so you do UFO.
I do IFO, and you UFO.
And so do you.
And so do I.
Welcome to the Connecticut UFO Show. I'm your host, Warren Scott, and this is my co-host, Mike Panichello, MUFON Connecticut State Director.
Hello, thank you for joining us today. We got an exciting show ahead of us.
Should be very interesting. We've got a special guest tonight to talk about anti-gravity, and we actually have a second special guest, our kind of recurring special guest and part of the show now, Mark D'Antonio.
Hi. Yep. Now, we also have in the news, we have some good stuff today, but we're not there yet. And then we are going to have Mark talk about his usual section, the science of it all. Yep. So it's going to be exciting. And now, what else we got going on? Well, we have a Skywatch coming up.
Oh, that's right. Yeah, Saturday night in Bristol.
Yep, in Bristol. It's a UFO hotspot. The details are on our website, and you can join us for dinner before if you guys want. We're going to a nice little organic burger place.
Going to have a telescope or more than one telescope?
Hopefully we're going to have more than one telescope. From what I understand, we're going to have some people bringing equipment, so it should be a good time. Maybe we'll have some stuff for our show for the next installment. We'll have some live video of something interesting.
Well, and eventually we'll be able to have everybody come to my observatory as well.
Great.
Yes.
And we'll do a nice show.
Which you're currently working on right now.
That's right. We almost got the dome finished today.
Wow, great.
That's great.
And I just blew a couple bucks on a very low-end Sony HD night vision camera. So
Nice.
maybe I've been watching people getting a lot of stuff on night vision that really is very interesting, those types of sightings, because when you look at the video, it doesn't look like it's faked. There's definitely something there in the night vision chip, but you don't see it with the naked eye. So that's very interesting. What is happening there? Any ideas on?
No. In the future, we're going to actually, in a future segment, a future show, I'm going to talk about night vision systems.
Great.
And I'm going to give people an idea where they can get some cheap ones, where they can get some moderately expensive ones, and if they have money to blow, where they can get the best ones on planet Earth.
Super. Oh, I look forward to that.
We're going to have a night vision camera. I got one. We're going to record it, and we're going to post it on our YouTube page.
Excellent.
So it's going to be really good. So what do we have tonight before we move into the news of it all? Why don't we talk about who our show is tonight?
Well, so tonight's program is on anti-gravity, which is how most people that have been studying UFOs presume that these vehicles use in terms of their propulsion systems. And so tonight we have a guest who's an expert in anti-gravity, Richard Crandall. We'll be bringing him on in a few minutes.
Oh, that's exciting. You know, it always makes sense. It's good that we're talking about this today because, you know, one of the things with UFO sightings is you see these reports come in of, like, you know, orange orbs, for example, or anything. They're going left, they're going right, they're going left. And so often people say, well, the technology that we have today is like ballistic. You only can go one direction. And even if you turn, it takes miles to turn. I mean, look at the fighter jet. They don't just turn on a dime. Yet these UFOs, they turn very quickly, supposedly.
Right, so inertialess propulsion.
At least that's what the observer tells you is happening.
Well,
and many times, in my role as the chief photo and video analyst for the Mutual UFO Network, when I see these videos come in, I got to tell you, you know, they don't do on the video what they say it did when they saw it with their eye.
Right.
So either they didn't capture it, or they're not really clear what happened themselves, and they're over time adding to it. You know, I don't know.
Well, that is definitely a recognized phenomenon, the way the memory tends to color things over time.
10 people report the same event 10 different ways.
Yeah.
Right. Although I think, you know, you can pretty much tell those samples of video where it does seem very compelling. And these orbs you mentioned, there was a recent capture, I think in Canada, there were 3, it might have been Chicago, but there were 3 orbs. It was kind of a dusk sighting. And the spheres move. At first, it looks like a triangular vehicle because the 3 balls are all synchronized. They're not moving in relation to one another. And then all of a sudden, they'll start moving amongst themselves, if you will. They behave almost as if like an AI swarm might behave or something.
But, you know, it's good that we're talking about this in tonight's show, the different types of propulsion.
Right.
Because, you know, in the end, all we want to do is present the evidence. This is one example, and we'll let the audience decide if we're full of
No, that's the scientific method, and the key thing is just to rely on what the data tells us as a starting
just remember
point.
MUFON's charter, right? It's the scientific investigation of UFOs for the benefit of humanity. the word scientific is there for a reason. It's there because we're speculating about things and going down a path that we can't show scientifically, or at least with some background in science.
Right.
So, you know, we're going to get there eventually, and that's really what it's all about, right?
Right.
Now, speaking of science, there's been some scientific discovery this week that's very interesting. Should we start moving into the news?
Let's go into the news.
All right, so now we're going to talk about what's new in the news. And now, new in the news. This week, some exciting news comes from NASA in regards to a probe that has discovered some interesting material on a moon around Saturn.
That's
so
right.
to talk about this, we're going to turn to Mark D'Antonio.
You know, I had to tell you, when I saw the news about this, I was like, it's exactly what I had hoped. Enceladus is a 300-mile diameter moon, all right? But it has an ocean underneath. It's an ocean underneath that icy mantle. That ocean, now it seems we've seen geysers coming out of Enceladus. Now, those geysers were picked up, and they also studied the outflow from these geysers, and they discovered something miraculous. That's hydrogen. Why is that important? It's very important because hydrogen is part of the possibilities for the hydrothermal vents we see on Earth. Even off the Juan de Fuca Ridge off Oregon, 3,000 meters down, you have this spewing hot water that's mineral laden, along with hydrogen sulfide.
Right? Is
hydrogen
it like
sulfide
volcanic venting?
Hydrogen sulfide is the key to creating life down there, because it's not photosynthetic life like on the surface.
Right.
It's chemosynthetic life. So now we see that Enceladus is showing signs that it might also be hosting its own hydrothermal vents. And in fact, when they did a nice infrared view of the south pole of Enceladus, where this is mostly occurring, you could actually see the hot spots around that area, and it was really, really interesting. This is a monumental discovery.
Right. But what's so fascinating, I mean, with the science fiction stories, and even when science sort of pseudoscience fact, they always talked about Europa as being this type of planet that was covered in ice, and they could see the stressing on the surface of the ice, and they suspected this activity might be going there. But why?
Enceladus, but Enceladus is 300 miles across.
Right. How big is Europa?
Europa is 1,900 miles across, so it's bigger.
Much bigger, right?
Its ocean is about 100 miles deep. That's cool, because that could be another place where we might find this particular hydrogen outgassing that might indicate hydrothermal vents there as well. But we're not even near that yet. We don't have a probe there right now.
So this was just pure luck? Was this just pure luck? The probe was going by, was capturing imagery from Enceladus, and then they happened to see it?
Remember, the Cassini mission is pretty much over fairly soon. But they actually used the Hubble Space Telescope to actually image geysers on Enceladus this time.
Okay.
But now, that didn't detect the hydrogen. I believe it was the Cassini that did that. Right. So they had a dual set of instruments. Put the two data streams
together, right, I see.
Right.
When it comes to UFOs, I always think it's interesting, because people always say, well, every place on Earth you think life doesn't exist, we find life.
Right.
Exactly.
So why is it so hard to believe that if you have these hostile environments on this planet and we find life, why can't we know that there's hostile environments out there?
That's right.
So it makes sense.
They found microbes on the outside of the International Space Station.
Right.
And in Jurassic Park, the man that played Ian Malcolm, that actor.
Right.
Okay, he played Ian Malcolm, right. Ian Malcolm said, life will find a way.
Attenborough,
and it does.
Attenborough.
It does,
right?
Yeah.
Okay.
But what's fascinating, though, is, now that if you think about the impacts of what this means, that the Drake equation, for example, if there's life on Earth, and now let's say that this discovery leads to finding life around one of these vents, let's say. It might take us another 50 years to get there, but let's say we're able to get a probe under the water, or in the water under the ice, and we can definitively say that there's life there. Now you have two planets in the same system with life. Wouldn't that then sort of extrapolate to the rest of the universe that life is probably a lot more prevalent than initial calculations?
It does give science the impetus it needs to take that leap of faith and say that there will be life elsewhere within our solar system for sure, since we might find it.
But would they say it's advanced life, or would they say, oh, it's just probably microbial?
No, it's microbial only here on Enceladus, but that doesn't mean anything. I'll tell you why it doesn't mean anything, because we have up to 40 billion chances just in our galaxy at the high end for planets like the Earth to be here. And that means that we would have a very good possibility of finding another life form out there that has reached some level of intelligence. Maybe not interstellar travel, but it's possible.
Okay. All right, I guess it's about time.
Well, hold on, there's one other story that was very interesting that came up in a whole other front, but sometimes relates a bit to anti-gravity, which is in the conspiracy realm. There was a investigator, and I believe he was a UFO investigator, but he started getting into paranormal and I believe even political investigation by a guy by the name of Bruno Borges, if I'm pronouncing his name correct. He was Portuguese, and he had been doing this investigation. Was very close with his family, but then boom, all of a sudden the guy's been missing. They can't find any evidence, but in his apartment it is covered head to toe like an altar to the paranormal. There's mathematical formula. There's an encrypted text written all over the entire apartment. It is literally like it might even be an art piece if you think about it. Someone might have done, and they're trying to get news about it. But it's interesting because you often hear within the UFO space when people try and talk about subjects that they are, they're being monitored by the government and this type of thing. And we'll touch upon that later in our interview.
That's a very good point, but that often happens in ufology. Look at Tesla. When he died, all of his stuff disappeared.
Right.
So, there's always something weird going on with the UFOs and conspiracies.
And
that's a whole discussion.
That's
right, and there's also there's always conspiracies, even when there isn't.
Right. Well, that's true, too. That'd be a great show for the future. And we'll definitely talk about it. But why don't we move into our new topic tonight, which is our guest that we're having on Skype. Our first ever Skype interview, by the way. If those of you that have been following our show since its inception last year, we have never done a Skype interview, so this is exciting. And we're having a guy coming from Texas, so we're not even doing it local. We're going out there.
Okay, so we've got the audio on. I think, Richard, can you hear us?
Yeah, I can hear you.
Okay, great. So, well, what we'll do is today we're doing the program on anti-gravity, and like I said, we're going to bring on in a second here Richard Crandall, who wrote this book, They All Told the Truth, the Anti-Gravity Papers. And this is an impressive book. I started reading it last week. I'm only about halfway through. It's 700 fairly intense pages. We'll ask Richard some questions about this book here in just a minute. But Richard joins us from Texas. He is a former engineer working with the aerospace and nuclear power industries, and several years back, about a decade ago, he came up with a novel theory on anti-gravity based upon the assumption, if you will, that the UFOs that people have been seeing and reporting and documenting indeed are real and indeed work on an anti-gravity principle. Richard, so thanks for joining us on our show tonight. Welcome. And I'd like to start off, I wanted to ask you specifically, when did you realize that anti-gravity had to be true, and why?
Nice to talk to you, Warren. This goes back quite a number of years for me, and I'll recall it for you. But back in about 1994, I went down to Roswell, New Mexico on a visit, and I went to a museum there, which is the International UFO Museum. And it relates to that supposed UFO crash in Roswell. Well, anyway, after leaving the museum, I was left with the strong impression that this phenomenon is real. And I was completely convinced. In fact, I made several other trips there not too long after. So that's what got me started. I finally realized at that point that this is something real. And so there's something that maybe physicists have overlooked, that, something we could do to mimic that. And so there it took off from that point. So
in '94, from this first visit then, within the next subsequent years, you started developing this theory. Is that right?
Yes.
Between 95 and 2000
that's when I started thinking about it.
Why don't you try to explain?
It was around about 1999 when I really got it pretty solid on paper, and I had all the equations you know, and so it was in a really solid form around 1999.
What did your, I'm sorry, how did the model come to be defined in terms like of, you know, you're thinking about these energy fields, and why don't you try to describe in your words what your model actually is, if you can try and do a concise explanation of how it would differ from, let's say, the way that physicists normally talk about molecules and atoms to laypersons, where you've got electrons, protons, and neutrons, and quarks down at the smaller level. So if you can try and keep it to my 5th grade understanding.
Okay, I'll do the best I can. Yeah, I think most people know, probably from high school, that atoms, you know, are composed of protons and neutrons in the nucleus, and then there's electrons that kind of buzz around that. And it's been further discovered about 50, 60 years ago that each proton and each neutron is composed of 3 smaller particles, which we call quarks. And as of today, the physicists still think that quarks are point particles and have no internal structure. Well, I was able to discover, well, yes, they do have an internal structure, and I was able to calculate that. And it turns out that a quark, rather than being a point particle, is actually a ring of several clusters, and each cluster in turn contains 7 particles within it. So I was able to do a model that was 2 levels of detail finer than what current physics says. And I can elaborate on any part of that if you want to do that.
Well, Mike, Mark, do you guys have any questions about this?
Actually, Richard, I wanted to know, if you could, what was the experiment that you ran to show this sublevel within quarks?
Okay, well, it is a way to follow the scientific method, and that's where you generate models, mathematical models, that create predictions, and you can run the numbers and calculate things, and then you can compare your calculations with actual experimental data. And so I ran the calculations, and I was able to calculate the masses of 13 of the more well-known subatomic particles. And then I was able to compare that with the experimentally measured values of those masses, of those particles, and it was very good agreement. It was within about 5%. I think one of them was about 0.9% off, which was not too bad. So in physics, that's considered not too bad.
Okay, thank you for that.
Now, this so from this theory, so to be the devil's advocate to you, right? There's people that will come out with various theories, and they'll say, oh, you know, I've discovered this property of the universe. Walter Russell is a well-known New Age philosopher who has this thought about how the universe is magnetic light, and I still don't understand really his book at all. Then there's people like Wal Thornhill and David Talbot who talk about the electric universe model, for example, and they have some data that's kind of compelling, that sort of, you know, talks about some of these things. So why, why is your theory, do you think, more valid than some of the other approaches that have been taken?
Well, yes, it's true. There's certainly a number of theories out there. And one of the ways that you can test a particular theory is, does it, first of all, generate testable predictions, you know, where you can go and do a measurement and verify something.
Right.
For one, it turns out most of those other theories sound good, but they've never generated something you can go and test and measure. So they're truly just theories. And then another level you can get to is, then can you try to build a device or something that operates based on the theory? And that's also something that these other theories have not done. So with my theory, not only do I have testable predictions, but I also have a way to design devices from that could be built and tested.
Can you explain that? Can we explain the, so you have this theory, but how does it relate to propulsion? Because that's what, like anti-grav. How do you translate this from your theory to possible practical applications?
Yes, and yes, it is a method of propulsion. That's what you would call it. And by the way, anti-gravity is kind of a misnomer, because that's not how these UFOs actually function. They're not negating gravity, they're not lessening the gravity of the Earth, but per the physics, what they're really doing is they are emitting a powerful gravity wave. And that wave that's being ejected produces a force on the object in the opposite direction. So it's like an action-reaction principle. You eject momentum or gravity waves in one direction, and then your craft gets propelled in the opposite direction. So it's not actually anti-gravity, it's just plain gravity.
So it's in a way you're getting the motion. It sounds like Newton's third law in a way. With for every action there's an equal and opposite reaction. But it seems as though there's got to be more going on. I mean, if you say you want to suspend a spacecraft floating around, and you see these things zipping around at Mach 20 or speed of light or however it knows, how I mean. What's fascinating is where is all that energy coming from? How is it being able to do whatever the operative principle is, the ejecting of...
when you're ready.
Yes,
okay, sure.
Yes, I understand. And it turns out I've discovered a very amazing mechanism for releasing that energy. And it is a form of nuclear energy, and it's very powerful. And the way that's done is, like I say, each quark is actually a ring, okay? You consider it like a ring. And there's a way to make that ring physically expand its diameter. And when that diameter expands, a tremendous amount of nuclear energy is released. But it's in a safe form. It's not like normal radiation like you get from, say, an atomic bomb. It's in the form of gravitational energy that gets released, and it's very strong. And so when those ships fly, they expand the rings of those quarks and release all that energy. And there's such a tremendous wave of gravitomagnetic energy released that it propels the ship in the opposite direction. Now, you did mention things like 90-degree turns, that kind of phenomenon. There's another effect that goes on, too. In these craft, they are actually warping space and time. And so you can consider them to be in their own, like, bubble of space-time. And once you're in your own bubble, you're completely disconnected from the usual laws of physics around you. So you can travel at any speed, any direction, make right-angle turns. It's no problem. So you've got your own local gravity field.
That was actually, I was going to ask this next question, but I think you're already in the process of answering it. I was going to ask, how do you overcome the inertia problem? And I think you're saying that if it's within a warp bubble, basically the universe is moving around you, and you're not even going anywhere.
That's interesting.
You could look at it that way. It's essentially the same. Yeah.
Otherwise, you'd be a pancake.
Well, absolutely. I mean, 6, 7 Gs and forget it. I mean, well, 12,
I like
maybe,
pancakes, but not when it's up against the wall of it.
Right. And so,
and essentially, too, there's no reason you couldn't travel faster than light. If you're in your own bubble, those laws of physics don't apply anymore.
That's correct. That's like the Alcubierre drive.
Right, exactly.
Miguel Alcubierre in '94, he came up with that tensor, and that was actually something that I thought was very interesting, because that whole theory also involves having a warp bubble around the ship, and you're not really within the normal X, Y, Z, all moving through time, four-dimensional universe that we exist in.
Right.
Now, how does this relate to, let's bring this back. So when Lazar is talking about propulsion on those ships that he worked on, they were using basically, in a way, your theory. So are you confirming Lazar's theory, or are you saying that he had it slightly off? I mean...
I understand, yeah. I'm actually confirming Lazar's story. But I'm not confirming his theory. I don't agree with his theory at all on how these devices work, and I have my own theory. And once I developed the theory, it told me that there's certain special shapes and certain configurations that would be required for a working, anti-gravity craft. And it turns out that what Lazar described in those ships, there's a part in there in the engine that fits my physics theory exactly. And so that's how I know he's telling the truth, because he would not have known about making those special conical shaped parts that are made of element 115. He would not have possibly known that without knowing the physics.
Right, yeah, I've got that page open in your book, And this is who said this is what Lazar said about the. This is his representation of 115, right? Or is that yours?
Yeah. You want me to go ahead and explain what you're looking at there?
Sure.
Yeah, what they would do is they would take, 10 or 15 discs of element 115, and they would fuse those together to make a cylinder, you see. And then once they've got the cylinder, then they further machine it into a cone.
Right.
And it turns out that conical shape is exactly what you need to make this work, because it creates a diverging field lines. Conical field lines will not work. Those are parallel field lines.
Right.
It takes a cone shape which has diverging field lines, and that's exactly what it takes to create this effect of enlarging the rings within the quarks.
I mean, is this something that we can manufacture? Because at the time Lazar was working at EG&G, he referenced 115, but it wasn't in the academic community, except maybe it had been touched on theoretically, but they hadn't gotten it out of a collider until, I think, 99 or 2000 or something. Isn't that? You probably know better than I, but, you know.
Yeah, I'm familiar with that. And sure enough, they have somewhat recently been able to create in the lab, in these colliders, they've created element 115. And there are supposedly different isotopes of that, depending on how many neutrons are in each nucleus. So the people at CERN, for instance, are claiming that, well, the lifetime of these particles is so brief, it's just on the order of maybe milliseconds, that it couldn't possibly have been used, say, in Lazar's craft, where he's claiming the use of 115. But Bob Lazar was aware of this announcement by CERN, and he came out and later said, you know, but he was told that there are several isotopes of 115 that are stable and will last very long.
Yeah, and that makes sense. Makes a lot of sense.
Yeah, and in fact, long before element 115 was discovered, we had already predicted as physicists that there would be an island of stability somewhere around the 110 to 120 area, and sure enough, there should be stable elements in that area.
Yeah, it's kind of like, you know, uranium or plutonium, you know, they're isotopes, and you've got, you know, 239, 235, 236, 234, you know, they've got the various isotopes of uranium, so that certainly makes sense in that regard.
Well, I would say a lot of the naysayers are saying, oh, CERN created this thing and it only lasts milliseconds, so that makes Bob Lazar's story completely false. That is not true. I am absolutely certain this story is true. There is no doubt it is 100% true. And as fantastic as the story is, why, you know, if it's that fantastic, why would he lie about just certain things? It's either all true or it's all false. You know, that's the way I look at it.
But because you saw these shapes that he drew, I mean, now he's a physicist, as he says, as some people don't believe. I think he is a physicist, but he you know, I'm having a senior moment. I lost my train of thought, so I'll come back to that one. But given your you know, your efforts here in this, and it is so sort of contentious with the standard, you know, academic physical model to some extent because it's changed. Although your model is different because you seem to say, hey, no, the standard model's correct, Einstein's correct. This is filling in the part that they're missing versus no, they're incorrect, like some people will say. And this is a theory is going to replace that other theory, right? So you're still saying Einstein and Newton and everything's still valid, and this is filling in some part of the spectrum of where these particles operate, or?
Yes, I'm not pulling any strange punches or any tricks here. I started with standard physics formulas. Einstein is still correct. What I've done is just further develop those formulas. And so it's just an orderly process from going from those formulas to the derivations of the equations I did. So there's nothing odd about this at all. And so physicists should have no problem with this at all. And that's if they would look at it.
But you feel you're not able to get your message out.
Yeah, it's a matter of getting the message out. And frankly, I've encountered like mile-high brick walls when trying to talk to physicists at universities. I have contacted hundreds of physicists, and I'm not getting any interest. They will not even look at this thing. Nothing.
Now,
most of them don't even reply back.
But have you had a colleague corroborate it, or a mathematician look at it, or have you gotten any third-party objective review that's supportive? Because I can't understand the need for needing corroboration on things.
Right, and that does help a lot with credibility, because after all, if you're just one person, who's going to believe you? Yeah. But yes, I do have a couple of qualified people that did review this, and one of them was a person that worked on secret projects at Ball Aerospace, and he took a look at my book. In fact, he passed it around to his colleagues at work, and they came back and said, wow, that is amazing. They said, you ought to get a Nobel Prize for this thing. So I was really happy to hear that.
Yeah, I bet.
And then there's another person who's a PhD in physics, and he's well known, and he did take a look at it. He actually got out a calculator and ran the numbers, and he said, wow, that hits it right on the head. He says, I can't find any errors, any mistakes in there, and so he evidently approved of it. But for various reasons, I don't want to name his name, and I'm not sure he would care to be known. So it's kind of what you call a silent witness. But I've got enough corroboration from people. I'm sure that it's okay.
But I mean,
plus,
why do you think
on top of that, the numbers speak for themselves, because you know my predictions, when you test them experimentally, they come out within 5%. So that's not bad. So it's certainly something to be looked at.
Why do you think the reluctance on the part of the physicists to want to review your work?
Well, I would say this. I've been through the same PhD type courses, you know, and studied the books that they have, and I know exactly where they're coming from, because current physics as it is says that these devices, it's impossible to do gravitational type stuff in the laboratory. On a small scale like this, physics says you cannot do it. It takes things large like planets and stars to get significant gravity fields. And yeah, current physics says if you look at the numbers, it's so weak you can't do it in the lab.
Right.
And that's why they won't look at this, because they quote unquote know it's not possible.
Well, I think one of the... Sorry, go ahead. Okay.
But yet it is possible.
Well, right. Well, I mean, like you said, I mean, you know, and myself having seen what, I don't know if it's extraterrestrial or not, but having seen an anti-gravity vehicle operating, I mean, I know it's real. So I like the fact that you started from that premise and kind of reverse engineered. And so now that sort of leads us to, you know, with these various other people you mentioned, T. Townsend Brown and David Hamill, right? That you're saying that their theories were correct because of the geometries of the cone and the triangle in their hardware. And now you've invented a machine that that we're talking about, and the CGC, or I can't remember what it was called, with this gravitomagnetic fluid. Can you talk a little bit about that? That's fascinating.
Yes, one of the devices I invented back in 2005, I actually built the device, and it produces a very strange, it's a visible fluid. And this fluid, you can see it with the eye, and it looks like maybe heat waves off of a hot object, or maybe it looks a little like a soap bubble film. And I had about a dozen witnesses that looked at this, and they could see that and said, wow, what is that? You know, that's a very strange thing. So what that is, according to my theory, is another form of gravity. And I'll just let you know, Einstein's equations predict as many as 4 different forms of gravity. And so what I was looking at was one of the other forms. So now we can actually have a way to look at that.
Well, I mean, this is in addition to, so you've got, you know, magnetism, gravitation, nuclear forces, strong and weak. Now you're saying that just out of that gravitation piece, there's 4 different variations of gravity.
This is no big secret. Physicists already know this. They already know that there's 4 types of gravity. They just don't talk about it publicly for whatever reason, but they know about it.
Okay.
No big secret there.
Now, so you've written this really impressive book, and I know that, and you've been working on some inventions, and you also have a website where you're putting some of your work up, right? ANTIGRAVITYEmbodiments.com. Is that correct? So
yes, it's called ANTIGRAVITYEmbodiments.com.
We'll post that on the website.
I also have a donation web page and also a video, if I can say those. But the donation page is on youcaring.com. It's called, and here, forgive me, but I wrote it down here. I only did this the other day, so I can't even remember my own name.
No worries.
Okay, it's called Why Does Nobody Care About Space Exploration Anymore? So once again, it's on youcaring.com, and you go to the search box and you just look up, why does nobody care about space exploration anymore? That's my donation site. Then there's also a video on YouTube, which is called Gravity Wave Propulsion is Here. Once again, Gravity Wave Propulsion is Here.
Right.
And so that's the three things I have out at the moment.
Is that the video that you pointed me to in the email you sent me earlier today?
Yes, that's the very one.
Okay,
yes.
thank you.
And what you're looking at in that video, those are not my devices. Those are three unrelated people, different inventors that have created these devices and tested them. And you can see in the video that all these devices are common, that they have common elements in them. And so what I've done is put that up so people can see that these devices do work. And you can take that video to any, even a high school science teacher, even that, and they can tell you that because of conservation of momentum, those devices should not work whatsoever. They should not move. And yet they do move, so they do work. So there's something going on that we can't explain with our current laws of physics. And my theory shows that these devices are ejecting a gravitational wave in one direction, and that causes a force in the other direction.
So for the layperson, if you were, when you say gravitational wave, because I'm not a scientist like these two guys are, would it be something like, so the spaceship goes up, the UFO goes into space, activates this, and then just rides it almost like a surfer riding a wave to its final location? Or like maybe another analogy might be Star Trek's warp core, where you fire up this warp drive, it emits a wave, and it literally folds space to push the ship. But the ship never actually moves. The space is moving because of the ship.
Well, there's two things that are going on. Two things. One is they are ejecting a gravitational wave, and that's what causes the push that moves the ship. And then plus, they're also generating a field around themselves of gravity, like a bubble. And that's how they can do the right angle turns and some of those sorts of things.
So if you're inside of one of these vehicles, inside this gravity bubble, and the vehicle is going to make a right turn, right? It's moving at some high velocity in this direction, and then it's got to go in this direction. So if you're in that room, it's like the room's not even moving? Is that kind of the idea?
Inside of the ship, you would feel nothing. There'd be no G-forces at all. You could see on the view screen outside what it looks like, and you could see things zipping around rapidly, but you would feel nothing at all.
Wow.
But what about when they're in space? Like, does it generate its own permanent field? Because if you stop, you'll just start floating.
Right, right.
Very interesting point. Yes, inside of the ship, it's not a weightless condition. They can set up the field so that they get normal gravity inside the ship, or whatever amount of gravity they want to generate.
You are a science guy. Didn't even know it, did you?
Every now and again.
So, well, Richard, we could talk about this all day. This is a fascinating subject. I think, like I said, I've managed to get through about half of the book. I look forward to trying to get through some of the. I'm a math guy, so I'm looking forward to getting just to play with some of the math. But it's a very interesting idea you have. I do think. What the people should know about, though, and what you might want to explain before we finish the segment is what I found so compelling about your idea was that inside the fundamental particle, if you will, which you call a vacuum, right, is that inside here there's basically two forces that are canceling each other out, and yet in the releasing of one of the forces or both of them, or uncoupling them, if you will, this is how it's releasing this magnetic or this gravitational wave, this gravitomagnetic field, right?
Yeah, I'll go into that just briefly. what I've discovered is that within a normal nucleus of an atom, there are extremely powerful gravitomagnetic fields present all the time. But due to their arrangement, they tend to cancel each other. And that's because, as many physicists know, the spins of the different nucleons are aligned opposite directions. So for every upspin, you've got usually a downspin to match it. So all the spins cancel, except there might be one or two left over that don't cancel. And those spins, you can also think of those as generating, each one generates its own gravitomagnetic field. So they all tend to cancel. So the trick is to get these things to uncancel. And the way you do that is through special alignments of the nuclei. And what you do is try to get a lot of the nuclei aligned a certain way to begin with, and then you create a conical shaped field, like I said earlier, which is a diverging field. And that will tend to pull these rings apart and also expand their diameter. And that's what releases that tremendous amount of energy, and it's in the form of a gravity wave. And in fact, if there weren't already very powerful gravity-like fields in a nucleus, we're not going anywhere in space. It would never work. And that's one thing I discovered early on. If there were not naturally produced gravity fields in atoms, we're not ever going anywhere.
Right.
But yet there are. Very lucky.
Well, that's good. Yeah, that'll help us in the future when they finally release this information to the public, which I'm pretty sure it exists. So, all right. Well, anything else from you guys?
No, this is very interesting. Thank you for coming on the show today and explaining this to us.
Yeah, and again, Richard's book, yes, They All Told the Truth, on Amazon, and I think it's on Barnes & Noble, the anti-gravity papers. It's a pretty interesting read so far. Now, some of it does get kind of heavy, but there's a lot that anybody can understand. And if you're interested in anti-gravity and UFOs, I highly recommend this book as a resource. It's extremely interesting material for a science-minded person.
I think it'll give you a very good understanding of maybe how they move.
Right.
You know, and that's so often one of the things that people say, like, well, these don't move normally.
Well, also, if Richard is indeed correct, what he's getting at is some of the physics that is just over the horizon for the general academia, okay? And as soon as they open their eyes, if this is true, this will become commonplace at some point.
Right.
And it'll be like, oh, yes, well, of course that's correct, or something like that. And we don't know that yet. I mean, over time, I mean, if he can get somebody else to corroborate and actually come out on record and say it, then, and work with him with this, then that might very well help him.
So it seems like the hardest thing right now for this to happen is we need like would be a power source, right? To generate this kind of power.
Well, that's what I was going to ask him about, you know, to create...
Maybe real quick, we're running out of time.
I know. A local gravity field, you would actually have to have a lot of mass in the standard model.
Yeah, how do you power it, Richard?
So
how would this be powered? Without 115? Can you do it without element 115?
Okay, I can try to answer that question. It turns out you do not have to have element 115. In fact, you don't need anything nuclear or any kind of nuclear reactions at all. It can all be done with just electricity, with high voltages or high magnetic fields. Either one, you can do it either way.
Hydrogen?
Now, if you do use 115 or something like that, then it's far more powerful. So I'm assuming or guessing that these UFOs that are interstellar, the really long distance ones, would probably use 115 because they're more powerful. Right. But just for local stuff like hopping around planets, you can easily use ones that are just electronic with no nuclear elements at all.
All right.
So how difficult would it be, do you think, to build such a local vehicle? Yeah, with the electrostatic.
I'd say it's very easy. There's one device out there I've noticed out on the web. There's a device that was supposedly built by SAIC secretly for the U.S. government, and it's called the ARV, which is Alien Reproduction Vehicle. There's even a diagram on my website of that. But that device, I do tend to understand how it works for my physics theory, And it looks to me like it's not that difficult to build. It's just, you know, the part that makes it work is called the capacitor section, which is down at the bottom. And it's just a bunch of metal plates in a certain configuration, and then they apply something like 1,000,000 volts to it, and there you go.
Wow.
Well, that's incredible. So I guess it is very possible for this to happen.
That'd be something that
And
we'll see in our lifetime. That'd be
something
terrific,
that can be done. So,
Yeah.
all right.
All right, well, thanks
Thank
again,
you.
Richard, for coming.
Thank you very
with
much
us.
for coming on to the show, and we do appreciate it.
Appreciate it a lot.
Thank you, Richard.
Thanks.
Thank you.
And now we will
We'll go on to
go
Mark.
to the
So
next section. Yeah, to Mark.
we'll move on to Mark. It's time for Mark's section, the science of it all.
You know, in keeping and following Richard, one of the things I wanted to mention is that the concept of gravity is something that is very perplexing, because if I take this iPhone and I drop it, I can calculate the force at which it drops. I can calculate the expected time it'll hit. I can calculate the damage that'll occur. Okay, but the bottom line is that I don't know anything about that fundamental force other than how to calculate its value.
Right.
So one of the things that was important was, and Einstein predicted that this would be available, something to see, something we could experimentally find, were things called gravity waves. Richard mentioned gravity waves several times, and he did it in the context of his physical
model,
structure, right. But we hadn't seen gravity waves
so far
up until we saw this merger of these two supermassive black holes out in the far universe. We saw these black holes collide. We saw the after effects, ripples in space,
Yeah, I remember
ripples of strange effect, light. Okay,
Right.
those ripples weren't water going into a pond. Those ripples were actually waves of gravity.
Right.
Finally, we detected them. Now, that could mean that we are on the cusp of finding out that maybe there are gravitational particles.
Right, like gravitons.
Right? And so on.
Right.
Okay? But the thing is, if we can find gravitons, then we can do something to gravity that we could already do to light, we can already do to magnetism,
Focus
we can already
it,
do
you
to
can
electricity.
reflect it,
We can
you
actually
can-
reflect it, we can refract it, we can bend it, we can change it, we can alter it. Because light, we know, has a dual nature.
Right.
It's both wave and it's particles. This wave and particle nature of light might extend to other things in the universe. It might extend to gravity. And if it extends to gravity, if gravity is a particle nature, then gravity is going to have the ability to have operations enacted on it like we can do to light.
Right.
And like we can do to magnetism, and like we can do to electricity. So those fundamental forces and characteristics of the universe are things that we don't really fully understand.
But we're starting to. We're like on the cusp, starting to see the horizon.
Exactly so, and that's the whole point. You know, we're on the cusp, and the thing is, we have a ways to go. Now, Michio Kaku, a famous astronomer, astrophysicist, okay, he says that we're maybe 300 years or so away from being a type 1 civilization on the Kardashev scale. Kardashev was a guy that created a scale of technical achievement that a civilization might reach: type 1, type 2, type 3, with type 3 being galactic in nature and able to expand throughout the galaxy. Type 1, able to take advantage of the full resources of its star and things like that. Type 2, sort of in the middle. But we're not even type 1. We're out here heading toward type 1.
0.9 maybe, or 0.87.
And as he often says, you know, we still burn dead things to get our energy. I mean, that's a big problem, isn't it? Because dead things finally, you know, do get used up.
They get used up,
right. So, you know, solar, wind. I mean, I developed windmills in the Gulf Stream that could actually sit in the Gulf Stream off Florida, far off Florida, and just slowly turn, generating thousands of kilowatts over time, so big and so massive, but so slow moving that a sea creature could just swim right through these fabric veins and never even affect them. A submarine could go through and say, hey, what was that? You know, I mean, so there's so much we can do. I created a bobber system, in fact. You know, I designed it, a bobber system for the waves. They're ceaseless.
they're getting
they
energy
never
out of those.
stop. So these would be perfect. So we have the ability to reach type 1, which is a place where we would have renewable resources, we don't use up resources on the planet. We actually have renewable sources.
We're sustainable. It's
and
a sustainable
solar,
society. Right.
Yeah, and solar energy is another thing. So, but let's talk about, let's go back to these black holes for a minute. A black hole is the remains, the final state of a very, very massive star.
Yeah.
Now, when stars shoot out radiation that's a radiative pressure, it's called, sticking, pushing out, okay? Think of it as a balloon. That is exactly balanced by the gravity trying to crush it. And when they reach that equilibrium, that's called hydrostatic equilibrium. Big words, but all it means is that the star is stable.
Right.
Now, suppose that big star starts to lose its fuel or run out of its fuel. Most stars burn hydrogen into helium. All right?
And they're good for 5 billion years.
And they're good for a few, right. And those stars are normal stars, what we call normal. But then, as the star ages, it uses up the hydrogen, and it begins burning helium into things like carbon.
Right.
And then carbon into other things, all the way until iron, which is number 26 in the periodic table.
Right.
Now, after iron, no star can produce that normally using normal burning. Yet we have a full periodic table.
Right.
That's because those elements come from when those stars finally explode in these catastrophic supernova.
Right.
Okay? It's hard to believe that you're made of things that were synthesized in the cores of stars, but you were.
We're star stuff, as
Yeah,
Carl
as
Sagan
Sagan would say, we are star stuff. Yeah, that's exactly right. But the point is, there's a certain size limit, okay, that is a famous limit, that if a star is above a certain size, it might continue to collapse.
Right.
It won't go supernova, it'll continue to collapse into a singularity.
Right.
All the mass of the star compressed into a singularity, a tiny little point. Now, the star still has massive gravity, but there's a certain distance away from that singularity around which light can't even escape,
right,
because it's too strong. Now, what does that mean, light can't escape? It means that light actually has mass. So you're getting pelted by these lights in here. You're getting pelted by little bits of light, okay? But you can't feel the force on you.
Well, the other side to that is, or something acts upon light that we don't understand. Right?
Our understanding is that light has a mass.
It would have to have some mass.
But see, light is dual nature. It's waves and it's particle nature.
Right.
So the point is, we found the gravity waves are gravitons, gravity particles just around the corner in our understanding. It's possible. And that's kind of, where I'm going with that. Now, the thing that's important is that we had an instrument here on the Earth. It's called the Laser Interferometry Gravitational Wave Observatory.
Right.
There's two of them.
Based on the Michelson-Morley interferometer.
One's in Louisiana, one's in Hanford, Washington, and both of them detected these ripples in space-time.
Right.
I always want to say that, ripples in space-time. That's something Captain Kirk would say.
Kind of scary in a way. You think like it's in time travel where we're breaking the fabric of space-time.
Right, exactly, right. We think about all these things, but so my feeling is that we're probably not too far away from having these gravitons, as part of our normal physical model.
And it'll probably be someone, if it's not Richard, it will be someone like him who will take that step of bringing the theory into an application. They'll be able to, because when you look at obviously there's the propulsion angle of this anti-gravity field, but the other things you can do with it, you can cloak, you can bend light with it. You can create a force field that will block asteroids as you're zipping through space, or whatever force fields are used for. A tractor beam, you can do a tractor beam with it. When they talk about the aliens will paralyze people, they say, oh, I felt like a heavy weight on my bed. I have to believe they're using a gravity technology.
That's probably, see, my feeling on that, though, and we're going to go down that path.
Well, let's not get to it.
My feeling is that in any case where there's potential abductions of people by aliens, most likely they know the human body, they know how the brain is an electrical system, and they can shut it off.
Right, probably.
All the right things to make us not be able to move.
Well, but there is the story of the woman floating from the New York apartment over the Brooklyn Bridge being taken up to a UFO, so they were suspending her you know,
So they
some
could
kind
have
of
been using a
beam.
gravity wave.
If she was telling the truth.
Yeah.
No,
there was
the
some-
two things that interest
that
me
story's
in this.
been corroborated though by
all
some
right.
very interesting.
Somebody saw her flying through the air? I don't
Yeah,
think so.
yeah, no, there was an ambassador from South America and his aide and his driver. They had 3 witnesses, but they didn't make an official report because, you know, they're political people. But no, there's an interesting book about that story, yeah.
Yeah, all right, 2 things interest me. One, what he's talking about the equations.
Right.
And the first thing I thought of when you mentioned this was, again, what we mentioned before was Ben Rich saying there was a misunderstanding in the equations. Once you correct it, we understood how it worked.
They got it. Wow.
So
I don't remember that quote. He said that along when we
he
can
said
take
it
ET
twice.
home. And,
yeah, he did.
you know, he's got the technology to take ET home.
So
whatever, right?
that was the whole thing. You know, we have the technology.
Oh, I
there's a
didn't
mistake
realize.
in the
Really?
equations.
I didn't hear that
we
part
have
of
the
his
ability
quote.
to take
Wow.
ET home. But the point is when
That's
he's mentioning
exciting.
this and he's talking about the equations,
The equation.
maybe it's similar. It's a nice little conspiracy to think of. I don't know.
Right.
But for to bring it back to the UFO side, to show the evidence, maybe someone else figured it out. Maybe you know, maybe this is somewhat common knowledge within the black budget world. I don't know.
That's right.
But the other thing that's interesting about it is the
and
power
also Tesla allegedly had figured it out, and Townsend Brown and some other people.
Yeah.
So maybe these people had figured it out, and they just buried it and kept it as secret information.
But the thing that interests me is
files.
the power source. It always seems like you're putting the cart before the horse. If you have the ability to generate this and you have the technology to do it, you got to have the power to do it. So that was interesting when he was talking about the power part of it.
Remember that in that Alcubierre drive concept that Miguel Alcubierre came up with in '94, that warp drive, had a warp bubble, same type of thing that he's actually talking about, that Richard Crandall was talking about. However, when Alcubierre did his calculations, he discovered that it would take the energy that would be the same as if you could convert the whole planet Jupiter to energy, which was a stupendously colossal impossible. And so I think that that's something that is going to be left for the future. But a redesign of that spacecraft a few years ago showed that they could actually do it with the mass of something like the Voyager spacecraft.
Wow.
And that's why,
huge,
that's a 10 to the 27th power reduction in mass requirement. And that's precisely why NASA funded a lab to start looking at this.
Well, so it shows that it's possible.
Right.
So we're about out of time tonight, guys.
Oh, come on.
I know.
We just got here.
Well, you know, the big guys in charge are saying it's time for it to go. So
Figures.
we have to move on.
Well, when you're having fun, you know, time.
But you know, I think what this
Time will skip around.
showed us, and I think I hope the audience
Time dilation.
realized.
The time dilation, that's right.
Let's do some Lorentz transforms.
You're interrupting my closing.
I'm sorry about that. We're geeking out.
We're doing this on purpose, just to play with you.
And differential equation
I'm going to have you
jokes.
abducted tonight.
Oh, again.
State Director, I have pull.
He has pull with the aliens, don't you?
So
Yeah,
anyway,
but he's going to
think...
muck up the anti-gravity drive, and they're going to be fixing that all week.
Oh, yeah, well, they better hire. I wonder if they have, like, space.
Well, you know, actually, I know where you're going with this. I had this thought today. So imagine you're this advanced race. They come to Earth, and they decide to take you for a ride. Well, I tell you what.
Hey.
They don't know how to fix their spaceships any better than I know how to fix my car. You know, so I don't understand the technology. I understand the internal combustion engine and the electricity and everything, but I couldn't fix my car.
Well,
so
that's good to know. All right, guys, this is it for tonight's show. If you want to attend our meetings, they're the first Saturday of every month. We are having Sky Watches now, so if you're interested in going
Saturday
to a
night,
Sky
April
Watch, Sky Watch
22nd.
April 22nd.
Yep.
We do it every other month until it gets cold, so there's plenty of chances to go on. Comments or questions, or if you have videos that you'd like to show us, send it to contact@mufonct.com or visit our website at mufonct.com for more information.
Or if you just want to yell at Mike.
Or if you just want to yell at Mike.
And come to our meeting first Saturday in May at A&D's Pizzeria.
Yeah, we're going to have
South
Enos
Windsor.
there. We're talking to Paul and Ben Eno, the radio personalities. But if you see this at our future time, just go to our meetings first Saturday of every month. Thank you all and have a good night.
Thank you very much. Good night.
Good night.
Good night.